Hey there, guys. So we're going to talk about electrical circuits. But before we get started, I want to give a nice thank you to the people at Jefferson Lab or JLab for this wonderful PowerPoint that I have revised and edited to make work for me. Lovely quote by Thomas Edison here. So when we talk about electricity, we've got to understand a few key words. One of those first words that we need to understand is what is voltage. Now, voltage is the force that pushes the current through the circuit, okay? It's the force that pushes. In this case, if you look at this picture, the gravity pushing and pulling on that water, that is that force that's moving the water along, okay? And then you have resistance. And it's exactly what you think it is. Resistance is something that gets in the way. It slows things down. It's like friction. And in this picture, the resistance would be the rocks inside the river. It's slowing that river down, okay? And then current. Current is the stuff that's actually moving. So in this picture, it's actual water that's moving, but in electricity, it's electrons that are moving. So there's two different kinds of circuits. You have your simple series circuit where things are just kind of lined up and you can see the wire just goes straight through. In a series circuit, if the wire is cut, all the lights go out. One light burns out, all the lights go out. And then you have a parallel circuit, and you can see it gets parallel because the wires make two lines that are parallel. Remember, parallel means side by side, never running into each other. There's lots of different pathways for electricity to travel in a parallel circuit. So if one light goes out, the others can still stay on. Here's a little bit more. Here's an example. A series circuit would be old school Christmas lights. It used to be that you had to go through and find out which Christmas light was burnt out so that you knew which one to fix, because if one light was out, the whole strand was out, you had to toss it. Nowadays, if one light goes out, you might have a couple out, but not all of them. And then you have parallel circuits, which is household lighting. So if the light were to go out in my office here, more than likely nothing would happen. The rest of the lights in the house would stay on. Even in my ceiling fan up there, even if one light bulb goes out in that ceiling fan, the other two would stay on. So we use diagrams to show electrical circuits, and there's a bunch of symbols that you need to know, and they are located in a PDF document at the bottom of the website for you to look at, but here's some simple ones. We have cell. Now, one cell is not a battery. A battery is a pack of cells, but in this case, we're going to call the battery the cell. Lamps are this wonderful symbol with an X. You've got switches. If it looks like this, that means it's open and electricity can't travel through it. When it's closed, electricity travels through it. And then we have our wires. Okay. When we look at this, so here we have our circuit. We have a light bulb. We have a battery. Okay, and we'll see that the current runs from positive to negative, but the electrons are going to go in the opposite direction, okay? Let me move myself here. And then if you look right here, no loop, no current, no light, okay? So if this gets broken, no light, okay? So when we measure current, we use something called amps, okay? And this is an ammeter, and you can see that it's actually part of the circuit, and it measures the current. Okay, it measures the electrons that are rolling on through that cycle. This is what a series circuit would look like. This is what a parallel circuit. Notice there's two lines running parallel of each other here. And we can see that we're going to be measuring the current. So in a series circuit, the current is the same all the way through, okay? All the way through. In a parallel circuit, the current gets split between the two lamps here. So 1 + 1 = 2, and then when it comes back together, we have 2 again. So the battery gives us 2, it splits here, it comes back together here, okay? So it's a shared current. So let's look at these. So here we have, is this the series or is this the parallel? Okay, it's the series circuit. So we remember that in the series circuit, it's the same all the way through. So the number 4 here should appear here and here. Let's check. Look at that. It is 4. So this is parallel. So right here, it says the battery is giving us 3 amps. So 1, 2, 3. So these should be 1, and this one should be what? 3. That's right. It's going to be 3. Okay. So let's talk about voltage. Now that's the push, okay? It's measured in volts on a voltmeter, which is kind of easy to remember because it's got the word volt in it. It kind of looks like this, and it's going to have two little wires that you connect and touch to the circuit, okay? Different cells give different voltages. You've heard of 9-volt batteries and AA batteries. They have different volts in them, okay? The bigger the voltage, the bigger the current. Unlike an ammeter, a voltmeter is connected across the components. And usually we talk about the potential difference when we're talking about voltage, but we're not going to be getting into that too much. We're not going to use that term. So this is kind of how it would look. You can measure the voltage here and here, or you can do it this way. So you can measure across all of that, okay? So now this is a little bit different. In voltage is shared. So this is kind of the opposite of current. So in current in a series circuit, it was the same across, but voltage is split in a series circuit. So 1.5 plus 1.5 equals 3. And then in a parallel circuit, it's the same. So you're going to have to go back and look at that, but the rules are kind of opposite of each other, okay? So if the voltage is one way, then the current is going to be another way. So you've got to go back and you've got to keep those things straight, okay? Go back and double check those. So here we have measuring current and voltage. There's going to be some diagrams. We're going to have to fill in the missing information. So here's the first one. We're going to copy that. So pause it, copy this into your notebook. Okay, here's the second one. Pause the video and copy this one into your notebook. When you're done copying them, think about the laws of current and voltage. Go back and review in this video. Go back and look at your notes and see if you can figure out what the answers are. Double check your work. Pause the video. Okay, are you ready for the answers? Let's check. Did you get it right? If you didn't, make sure you copy those in correctly, okay? And then we have Ohm's law, which is I equals V over R, which means current is voltage divided by resistance. So if you memorize this, and you're going to see this in your physics class later in your careers, you can solve for any of those three variables with this formula. You need to remember this formula. It's very, very important. All right, rewatch this video if you get confused. Take your notes, write your diagrams. If you have any questions, check with your teacher, check with me. Watch some of those great videos I have for you. Okay, guys?